Hi everyone, welcome back to Pine Hollow Auto Diagnostics. Today we have a very interesting car in the shop. 2015 Lexus IS250. It's a V6 2.5 direct injected. Customer complaint is that it idles at over 2,000 RPM. When it's warmed up, it's screaming 2,000 RPM. It drives fine apparently. No codes are set, no check engine light, just a super high idle. This one's going to be interesting. So what's the history of this car? It's owned by a student here at Penn State University. He bought it maybe a month ago, and apparently the previous owner said they changed the throttle body. See, it's shiny and new. I don't know if it's OEM or not. It might be. But why did they change the throttle body? I mean, the car drove fine, and then this idle problem just came out of nowhere. It started idling super high. At some point, a few weeks ago, he reached out, and he was busy, couldn't bring the car over. He said he disconnected the battery. For 10 minutes, reconnected it, and the car was fine for 2 days. Idled fine, normal, and then the problem came back. So he finally brought it here for diagnosis. I didn't believe the symptoms at first. I mean, certainly it would at least set some kind of code. Nope, no codes, and it idles super high. Okay, a couple other customer complaints. He said these buttons here, this Eco, Normal, Sport, and these buttons just don't work. And then the power mirrors, I think the left one, let's see, the left one goes up and down and not left and right, and then the right one is completely dead in the water. So I'm sure that's not related to the idle problem. I don't know about this, but let's plug in a scanner, start from scratch, run it, see what happens. Alright, so we're going to use the TOPDON Phoenix Plus scanner today. It's they're working on getting it to perfection. It's not quite there yet, but I'm going to use it as my daily driver from now on. So first thing I want to do is jump into OBD2 and just see if all the monitors are ran, if it's stored any codes in this, part of the computer, the global side. So all monitors ran, no codes, everything's freaking happy. Let's enter. No fault code. Read live data. Let's do the basic data, make sure it's in fuel control. We'll look at throttle position, mass airflow, engine coolant temp, engine RPM, equivalence ratio, bank 1, sensor 1. I don't know why it's listed twice, bank 2, sensor 1, and long-term trims, the downstream oxygen sensors, and then short-term trims. And we can plot relative throttle position, because this problem, you would swear it has to do with the throttle body, that it's not closing or something. So that's 14 PIDs here. Let's just see what's what. So 18.4 in the absolute throttle position, and relative, so I'm pushing the gas down all the way. I guess it's not responding when the engine's off. So long-term memory is probably a few percent. Let's fire it up, see what happens. Alright, here we go. Let's see what happens here. So lambda's on the money, 20 grams per second, 1700 RPM. Look, it went up to 2000, 2100. And it's just going to stay there forever. So how does this make any sense? The throttle body dropped to 18%, but the RPMs went up. That's a really neat capture. Fuel trims are going negative. We're still in fuel control. 8.8 grams per second. I'm going to rev it a little bit. Look at this. Insanity. Let's shut it off. It goes to 14%, back to 18%. Key on. The throttle didn't move from 18%. That's as low as it goes. So there was fuel cut and then it came back. 2200 RPM, just like the customer said. And why can't the throttle close anymore? Your downstream oxygen sensors are warming up. It's still in fuel control. Everything looks great. They're warming up. Like I said, this car is possessed. What could possibly cause this symptom? Alright, so in the OEM side, there's a lot more information dealing with this electronic throttle control. Now, closed throttle position switch, that's on. Throttle fully closed learn, 0.68. Throttle idle position is on. There's no current going to the throttle body. Duty percent 20, and then close. So the throttle body basically in default mode, it's about 20% open, and then from there the duty cycle can open it or reverse close it for idle speed. So if it's in limp mode, if you unplug the throttle body, it's just going to be stuck at 20%. You'll have this high idle. Throttle motor duty close and open, so it's 0 and 0. Throttle position command 1.02. Throttle require position 1.02. Throttle position number 1, number 2. So it has, you know, 2 sensors obviously. But let's run it, see what happens. So is it trying to close it? 18%. It's trying to close it a little bit. So if I rev it up, see, it opens it, closes it. I think it should close more than 18%. So right now we're at 0.9, and we're supposed to be at 0.68. That's fully closed. So is this computer just not calibrated? It's not setting a P0505 code like, you know, throttle or idle speed out of range or anything. So this is crazy. The computer's commanding the throttle at this level. If I shut it off, see, it went to 14 because the computer told it to close all the way, and then it shut it off. So 18.4 it looks like, or 0.92 is where it's default state. Okay, let's fire it up. .02. It's actually opening it a little bit. See, now it's trying to close it a little bit. Went down to 18. 0.9 is the desired position, command. But the fully closed learn is 0.7. So is there some kind of special function to recalibrate this idle? Learning value reset, perhaps? Manual throttle match? Wonder what that does. So let me read this and we'll see. So this manual throttle match, self-learning value reset, turn switch on, and then connect diagnosis tool, go to self-learning value reset. That resets the fuel trims. Idle learning, turn ignition switch to off, wait for at least 30 seconds, start engine and preheat until the coolant temp is at 80 C. Note, start learning when engine coolant is above 80 C. After engine warming up, place shift lever into P position. Stay idle for 5 minutes with AC and accessories off. Make sure idle speed is within standard scope. Check idle speed. If idle speed is out of specified scope, please confirm the following procedures. Preheat engine, drive vehicle 6 miles per hour, place in P, repeat procedure B and C, check if idle is within specified scope. So I don't know if there is, you know, we can do learning value reset. Okay. Okay. And that's it. So you turn it off for 30 seconds, right? Let's read the instructions again. And we'll start engine, preheat it. It's in P. And stay idle for 5 minutes with AC and all accessories off. That's all it's supposed to do it on its own. Okay? So I think that was 30 seconds. See, you just kicked up. It was starting to drop and then it kicked up. So let me graph all the throttles again with the RPM and see when that happens, what happens to our throttle position. So my question is, why is throttle sensor position showing 0%? If I rev it up a little bit, does it think this is closed? But 0.68, it's 0.2 of a volt off. This really blows my mind. I think we have to go to the throttle body and physically check what, where the flap is. Alright, so here's the throttle body. Here's scan data. So right now it's de-energized. Let me try to push it closed. We'll see what the position reads. 0.68. 0.92 is like the default. Okay. So 0.68 is definitely fully closed. I'm going to gently, maybe I should use a tool just in case it decides to activate so it doesn't snap off your finger. So fully open, 4.1, 63%. That's what it reads on the throttle. Okay. Back down, 0, and when I push it in, it's still 0. But the throttle position number 1 sensor reads 0.68. So the voltage makes sense. This throttle sensor position, not exactly sure what that means. Let me find all the data PIDs just to make sure, there's absolute throttle position, relative throttle position, see if this thing is synchronized. Okay, so throttle sensor volt percent, if I close it all the way to 0.68, it should drop to about 13.7%. Okay? Now let's open it up all the way. all the way up. 87%. Okay. So 14 should be the minimum at 0.68. We're right here. So this throttle body is not really being closed with the duty cycle, right? I mean, it definitely can travel, but for some reason the computer's not commanding it more closed to reduce the idle speed. And I don't know if that's the correct part number. It may be, but you know, on eBay you can find something similar with the right part number and it will not work. So do we call throttle body? I don't know. I don't know. We can scope. I mean, it's in control, but it's just not the correct control. Very, very strange, and no code set. Alright, so I'm going to start it up with the mass airflow sensor unplugged, and then we'll manually manipulate the throttle plate to see if the car can physically idle down. Alright, here we go. Check engine lights on, mass airflow is disconnected. I'm just gonna try. Oh, did you see that? It closed, but the idle went up. What the heck? How does that make any sense? Maybe the cam's phased and... Okay, so now I'm in control of the throttle. So it should be at like 0.75 to reduce the RPMs to something reasonable. Or 15% right there. Okay? Very interesting. Okay, well let's clear all the codes out. Read fault code. I'm sure it's set. Throttle body codes, mass airflow codes, blah 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 blah. Clear DTCs. Yes. Okay. Okay, we still have our intake air temp sensor. Go back to data stream. See what this throttle does after a code clear. Okay, so it's running in limp mode because the mass airflow is unplugged. We're at 0.92. Okay, so it's not happy without the mass airflow. Okay, so if I try to open the throttle, look at the duty cycle close. It goes up. It's trying to close it. If I try to help it out, it goes to 0. And the open goes more. So it wants the throttle to be right here, but why? I don't understand. Alright, so I'm going to try to recreate what the customer did. I disconnected the negative battery terminal. We're going to leave it off for a few minutes. Reconnect it, see if anything changes at all. Alright, it's been about 10 minutes. Let's reconnect the battery. Okay. See what happens. Should probably tighten up that terminal. So the terminal here does look quite corroded, and we definitely need a good ground for this thing to be happy. So let me clean that out really well, reconnect it tight, and we'll fire this thing up. Alright, here we go. Let's fire it up. Let's see if the idle comes down to something reasonable. It's already a lot lower. Let me log into Lexus. We'll look at those data PIDs again. So is it possible that a bad battery ground could cause this? I don't know. I really don't know. Alright, so now we're idling at 1300 RPM, which is a lot better than 2100 RPM. 0.82, 16% on whatever, the absolute throttle position, instead of 18. So it's down a little bit, like half a volt. We should be like 0.75 instead of 0.82. Throttle is definitely, you know, going against the spring. It's commanded to here. 0.82. Should we drive it and see if it does anything different? Well, look, it's a miracle. I just put it in drive, or put it in reverse, started backing out, and then I'm like, hey, I gotta wipe the window because the window is really bad and we're driving in the rain. Put it back in park. We're down to 650 RPM, down to 0.72 on the throttle, so it learned. It actually learned. I'm gonna write these numbers down, take a screenshot. So is it fixed, or is it only fixed for 2 days? Okay, so in drive, it's fully warmed up, 550 RPM, 4.8 grams per second. We'll put it in park. Uh-oh. It doesn't want to come back down. So the problem is back. Is it going to come back down? Here it comes. So does he have a transmission problem? So we're coming down, 0.78. This is very interesting. So we'll let it stabilize here. So if there's too much drag on the transmission, when you're in gear, it's going to keep ramping up the throttle to, you know, to compensate. Then you put it back in park. So this could be a transmission problem, not a throttle control problem. That's pretty crazy. Okay, now we're getting somewhere. And what about the snow buttons and the traction buttons? See, that doesn't work, this doesn't work, this doesn't work. Is that tied to the transmission, perhaps? So now we're back to 700 RPM, 0.74. Let's put it in gear. It's dragging a lot. Look, it has to bump up the throttle, I'm sure. 450 RPM in park. Let's put it in reverse. Let's take a picture of that. So I'm sure that throttle body is going to ramp this up. Look at that, 0.8. Yep, it's ramping up. It's trying to lift the idle because in gear it's dragging too much. And now in neutral, RPM should start coming down again. The car's not smart enough to figure out that there's a transmission issue here. Makes sense. Makes perfect sense. Well, we'll still take it for a test drive and then look into transmission, whatever, drag. I don't know, maybe the fluid needs to be changed. Well, right now it's totally happy and neutral. It relearned. So, very, very interesting. Customer complaint number 2. Why was this whole system offline? They weren't lit up. They weren't working. That's because it's disconnected. Huh, how about that? And we see some brown stains, like coffee was spilt on here, so they probably disconnected it because this thing shorted out. Alright, we're getting there. Those USBs are disgusting. Oh yeah, definitely some spillage going on all over. So, mystery number 2 solved. Alright, a little bonus footage. Let's look at these power mirrors. So, I'm in the master switch. All the switches are on a network, which is crazy. But that's nice that you can read live data. So here's the mirror switch. Left, right, and the 4 arrows. So if I press the L, there you go, mirror switch left on. If I press the right, that works. If I press up, hey look, it came back to life. Okay, down. What about right? So the switch works, and then left, that works too. I heard something. You try to do something. Up and down is fine. So the controls are fine, so something mechanically. Hear that? It's like a ghost. Now the right stopped working, even though the switch works fine. Let's go to the mirror itself. So each mirror is also a module. You see how many modules there are. So mirror, let's go to the left one, which it kind of works. Data stream. We're reading data from the mirror. Okay. Horizontal, battery positive, vertical sensor. Okay, so left. So the sensor works if I push it by hand. But the motor's not happy. Let's go to the right mirror. Data stream. Alright, so look at the scan data. I'm going to push this. Yep, it definitely changes. Vertical definitely changes. So I guess these mirrors are just, maybe the motors are seized up. It's funny that it worked for a little while. But mirrors are just dead in the water. The controls are fine. And that's it. So none of the problems on this modern Lexus can we fix, no parts required. We can't even fix them with parts required. I mean, what is the guy gonna do? Needs a transmission, a button assembly, and both mirrors. That sounds pretty expensive. I think you'll just keep driving it the way it is. So you brought it in for diagnostics. So, you know, if you're a shop and you say, you know, we don't charge for diagnostic time, you're not going to make any money on this car. You have to charge for diagnostic time. Now the customer knows exactly what it would take to fix this Lexus, and if he can keep driving it the way it is, that's his decision, but we did our job, and that's it. So thanks a lot for watching, and we'll see you on the next one. Bye-bye.